Welcome all my dear students of TYBSc physics class. Today in this lecture we are going to see two more important programs which are very important for exam point of view, as well as these programs are also very important in practical purpose. So, these programs are nothing but first program, addition of matrices, two matrices using array, and second program is nothing but multiplication of two matrices using array. In 11th science, 12th science, FYBSc, SYBSc and TYBSc mathematics, as well as in physics, we studied the addition of matrix or addition of two matrices, as well as we also studied in mathematics, SYBSc mathematics, FYBSc mathematics, multiplication of two matrices. Before starting this program, we should know the algorithm or flowchart, or in a simple manner I can say that we should know the procedure of addition of two matrices, how two matrices are added and how we get the resultant matrices, as well as we should know the procedure for multiplication of two matrices. Suppose there are two matrices, matrix A and matrix B, and when we make a multiplication or when we take the multiplication of two matrices, that is A and B, we get the third resultant matrix that is C. Then when we take the multiplication of two matrix A and matrix B, then how we get the resultant matrix C? And I think you are very familiar or you are aware from this procedure, though we are going to briefly discuss how the addition of two matrices takes place and how the multiplication of two matrices takes place. First of all, we are going to see the addition of two matrices. One of that, if there are two matrix, suppose this is matrix A, whose contents are A1, B1, C1, D1. These are the element of the matrix A. Suppose this matrix A. And second matrix, suppose A2, B2, C2 and D2 are the elements of second matrix, say B. If we take the addition or multiplication of these two matrices, then we get the resultant matrix. But when the addition or subtraction of two matrices is possible, remember that the corresponding rows and columns of A and B should be equal. What I say? We can obtain the resultant matrix, that is, we can obtain the addition of two matrices or subtraction of two matrices if and only if the corresponding rows and corresponding columns of two matrices A and B must be equal, otherwise it is not possible. Okay. So, if we take the addition, then addition is simply the addition of corresponding corresponding elements, that is, this element is added with this element. Now, B1 plus B2. This element is added with this element. Then C1 plus C2. This element is added with this element. And lastly, D1 plus D2. In this way, we take the addition of two matrices. By the same procedure, we can obtain the difference or subtraction by replacing the plus sign by minus sign. In this way, we can obtain the addition of two matrices. Okay. Now this matrix is 2 by 2 matrix. This is also 2 by 2 matrix, and resultant matrix is also 2 by 2 matrix. And hence I am telling you, tell you that what when the result will get, if the corresponding rows and columns of A and B are equal, then and then addition or subtraction of two matrices is possible. Okay. So for this purpose, this is the simple procedure. Now we are going to obtain, or we can see how program we can write the program. See, this is a program for addition of two matrices. For our convenience, we take two matrices, matrix 1 and matrix 2. This is for our convenience. We can change the element. Suppose if we are going to obtain the addition of two matrices which are 2 by 2, then instead of 10 we can write 2, 2. These are represent first. This is, see here, this is matrix 1 is the name of array, and this array contains 10 rows and 10 columns. Then second matrix, name of second matrix is matrix 2, and element of second matrix, that is there are 10 rows and 10 elements. And when we added or subtracted two matrices whose size is 10 by 10, we also get the resultant matrix whose element size or rows and columns are also 10 by 10. Okay. In this way, this is the resultant matrix. This is matrix B and this is matrix A, or matrix 1, matrix 2, matrix 3. Okay. So, see here, just a minute. If it is not possible, that means what? A1, B1, C1, D1. This is the matrix A, and this is matrix second, that is A2, B2, C2. Okay. If, see here, when we enter the elements of first matrix by using proper statement or syntax, also we enter the elements of second matrix by the same way by using proper syntax. Then, and if both the matrices are having same rows and same column, then result is possible. Otherwise, result is not possible. For this purpose, see here, this is the if statement. This is the if statement. That means what? If this condition is true, then this if block is executed. If there are A1, B1, C1, D1, E1 and F1. See here, this is the 2 rows and 3 columns. So here addition or subtraction of two matrices is not possible. At that time condition is not true and this block is not executed. If block is not executed, and if condition is not true, then simply this if block of if statement is skipped and else block is executed when condition is false. And what will be the result? Addition or subtraction is not possible, because obviously the number of rows and number of columns of two different matrices which we are going to consider for addition or multiplication is not equal. Okay. So, see here the content of the program. Here in matrix first, number of rows and number of columns are integer number. In matrix second, number of columns and number of rows are also integer number. And resultant matrix, that is third matrix, is also having the number of rows and number of columns, that is also integer number. So here matrix 1, matrix 2 and matrix 3, these are the array name. Here we are consider three arrays, matrix 1, matrix 2 and matrix 3. First array having 10 rows and 10 columns, that is for 10 element for rows and 10 element for columns, R and C. Second element, that is second matrix, is also having 10 rows and 10 column. And third matrix, that is resultant matrix, is also 10 elements, 10 for rows and 10 for columns. That's why we define the array like this way. Okay. Now, when we solve the two matrices, or when we carry the addition or subtraction of two matrices, then obviously we have to consider, we have to count, or we have to consider rows and column. Therefore, a rows number and column number is also integer. So, R1 first matrices first matrix having R1 rows and C1 columns. If first matrix is 2 by 2, then obviously that matrix having R1 is equal to 2, that is 2 rows, and C1, that is 2 column. So, this is 2 by 2 matrix. Okay. Now, our second matrix is also having 2 rows, that is R2 is equal to 2 and C2 is equal to 2 columns. So, R1 and R2 are also integer number, and when we enter the number, when we enter the element of first matrix, element of second matrix, and then carry the addition or subtraction, at that time we should have to consider another variable. That means one of them is I and another is J. In this way we define the 3 arrays and required variables R1, C1, R2, C2 and I and J. Okay. Now, this is the usual way. By usual method we can use CLR, SCR, that is this syntax used for clear the screen. Now, when we consider the first matrix, that is suppose having 2 rows and 2 columns, this is matrix first or A, then how we can enter the element of matrix A to the computer. For this purpose, this statement is useful. Printf how many. First of all, we have to tell to the computer that how many rows and how many columns the matrix having. Okay. So, we have to tell to computer that how many rows and how many columns. Suppose we are using 2 by 2 matrix, then their columns are 2 and rows are 2, rows are 2 and columns are 2. So, here when we press 2 and 2, then at that time these 2 rows and 2 columns are scan or read and accept by this statement, scan a percentage D and percentage D. This percentage D is for R1 and this percentage D for column. And when we enter the number of columns and number of rows to the computer through keyboard, at that time address of that rows and address of columns are mentioned by this operator, address operator R1 for rows and address operator for C1 for columns. In this way we can enter and computer can accept and store the number of rows and number of column or column number and rows number in a memory location through this address operator. By the same way, when we enter the number of rows and number of columns, suppose this is also 2 by 2 matrix, then there is 2 rows and there are 2 rows and 2 columns. So again we have to tell to computer that how many number rows and columns in matrix 2. And when we use 2 by 2 matrix, then we are also again going to enter the number 2 space 2, and that's rows number and column number are scanned by the computer through this by using this syntax. Again this is for a row and this is for column, and this gives the address of first row, second row and second column of second matrix. Okay. In this way we can enter and computer can read and store the rows number of first matrix and rows number of second matrix in computer. Okay. Now, when the addition and multiplication is possible, again I am going to tell you that if the number of rows of first matrix or matrix A and number of rows and columns of second matrix are equal, then and then addition or multiplication of two matrices is possible. Otherwise, addition or multiplication of two matrices is not possible if number of rows and columns of first matrix and number of rows and column of second matrix is not equal or not equal. Okay. So now suppose number of rows and columns of first matrix and number of rows and columns of second matrix are equal, then here we use 2 by 2 matrix, here also we use 2 by 2 matrix, and hence this condition is true. If this, what I say here, if R1 is equal to R2 and C1 is equal to C2, if rows of first matrix and rows of second matrix are equal, also column of first matrix and column of second matrix are equal, if this condition is true, then this statement, if statement or body of if is executed. We are going to see how the body of this if statement. Otherwise, if this condition is false, then this is skipped and this else statement is executed and result will be displayed on the screen like that. Addition or subtraction is not possible, gets is stop. Okay. Now, if the condition is true, then see how the execution or how the addition or subtraction of the matrix takes place. So again here printf enter. Now here suppose we want to make addition. So new line, addition or subtraction. Addition possible. When addition is possible, let me know. If condition is true, then addition is possible. Or when condition is true, then subtraction is also possible. Then second, printf. Okay. Again, input of first matrix or matrix 1. What is the input? We should supply the input. Suppose there are 2 by 2 matrix, 8 elements, and we have to enter that 8 elements through keyboard. So this is the syntax for that purpose, and every element should be on new line. Okay. See here again, if condition is true, then this message is displayed on the screen. Otherwise, this is skip and the final result, that is addition or multiplication is not, addition or subtraction is not possible. But now here condition is true. If we are going to use the program for addition, then message will be displayed, addition is possible. Or we are going to use the program for subtraction, then here we can change the word subtraction, and then subtraction is possible if condition is true. Then when this message is displayed, again computer asks enter the numbers, elements, that is 2 by 2 elements, 2 by 2 first and 2 by 2, that means 4 and 4. We have to enter 8 elements through keyboard to the computer. Okay. Now this is done, this entering of 8 element is done with the help of for loop, because we enter the number or element one by one. Suppose first I is equal to 0. We have to initialize I is less than or equal to here row 1, then I plus plus. Okay, sorry, this is not termination. This is not terminated. Okay. Now here this statement is for row subscript R1, R2 and R3. Again, as well as row, we have to enter the element for column. Therefore, J for column, J is equal to 0, then J is less than or equal to C1, and every time J plus plus. That means what? When we, this is for column subscript. Remember that this is this statement for row subscript and this is statement for column subscript. Okay. Now, with the help of these two statements, we can enter the number of elements, that is number of rows and number of element in rows and number of element in column. Okay. Now, when we enter the element, suppose 2 by 2 matrix, there are 2 by 2 matrix, then there are 8 elements. When we enter these 8 elements to the computer, at that time computer is going to read that computer element and store in memory at a particular location by using what? Address operator. Okay. So, for that purpose we have to use scanf function. Scanf function again %d. Okay. Here we use only single d because we use the address of matrix first element, that is row and column. Okay. By using this single statement, we entered one by one. Suppose 2 by 2, that is 4 element. This condition is true until the 4 element. When we enter the 5th element for rows, then condition is false and the further execution is stopped. At the same time, when we enter the element for column, there are also 4 element, 2 element for first, 2 columns in first matrix and 2 columns in second matrix, 2 and 2, 4. If we try to enter the 5th number, that is 5th column, it is not possible. It is not allowed. So, execution will be stopped. And when we entered 4 element for rows and 4 element for column, and these elements are read by the computer and stored in this array element. This is the array, matrix 1 is the array name, and these are having ith element, that is ith row and jth column. Okay. And we define the ith element, that is 10 and 10. Okay. Now, by the same way, this procedure is for only enter the element of matrix 1. Okay. Now, by the same way we can enter, that is printf, by using this statement printf. How is here? New line, input matrix 2, new line. Okay. Again here, for I is equal to 0, I is less than equal to R2 and I plus plus, and for j is equal to 0, j is less than or equal to C2 and j plus plus. And again, just like when we by using this block, we enter the elements rows of elements of rows and elements of column of first matrix, and here these are represent for second matrix. So, scanf %d, then ampersand R2 and ampersand C2. Okay. Instead of this, simply we use matrix 2 ith element and jth element of matrix 2. Okay. So, remember that these statements are useful for entering the numbers or entering the elements of second matrix by user, and read and accept that element and store to the memory location by using address operator by computer for matrix 2, and this is for matrix 1. Okay. Matrix 1, and this is for matrix 2. Okay. Now, when we entered and computer read and scan and store the element of first matrix and second matrix, then next procedure is very important. Okay. After this, if addition is there, then sum is equal to sum plus here ampersand matrix, we can say sorry, not sum, here we have to use the addition matrix 1 element J, rows and columns element, matrix 2 element of rows and element of columns. And these is, with the help of these two statements, computer added the corresponding element of first matrix and second matrix and assigned them to the third matrix, matrix third I and J. This is assigned to this. Okay. In this way, by using this statement, computer can add the corresponding element of first matrix and second matrix and assign them the columns and rows of third matrix. Okay. And after doing this addition, computer should have to display the result, so that, okay, see here, rows 1, okay. Now this is the body, this is first statement, okay, this is the body. Now result, how result is displayed on the computer screen, that for that purpose, next statement, first printf, this statement is useful to result the display, and this result is nothing but sum, but sum is equal to so, and this sum should be on new line. Okay, so take new line operator, that means every element should be comes on a new line. This is done by this computer. Okay. Again, for this purpose, sum or difference or addition or subtraction of corresponding elements are also carried out one by one. So for that purpose, for I is equal to 0, I is less than R1, say suppose R1, okay, then I plus plus. Also, this should be carried out at the same way by using entering for j is equal to 0, j is less than C1 and j plus plus. Okay. Remember that this for loop is executed till the condition is true, that is number of rows and number of columns are equal. Then last printf, what computer is going to print? Computer is going to print the element of the resultant matrix, and every element, resultant element, there should be tab. So use this /t, that is tab operator, and what here going to print, that is sum. Okay, sum, say sum, or simply the third resultant matrix, matrix third rows and columns of third matrix. In this way, by using this statement, computer can display the resultant matrix, that is third matrix, on the screen. Okay. And lastly, when we take the addition or subtraction of first corresponding rows with corresponding rows of second matrix, then resultant matrix is also the addition of first element of first matrix and second element of second matrix is on the same row of third matrix. So here, and after then second row second matrix. Second row, first matrix, second row, second matrix result will also occur on second rows of third matrix. So that is on new line. So printf new line operator simply, and this is the statement. Then else. Okay, see here, if condition is true, then all these statements are executed up to this brasa. That means this is the body of if statement. And when this body is executed, if condition is true. If condition is false, that is number of rows of first matrix and number of rows of second matrix are not equal, then this body of if statement is not executed. It skip, and the else body, that is this body, is executed, and this one is preserved. Printf new line addition or say subtraction is not possible, new line, and get ch, and lastly this. Here program is closed. In this way we can carry out the addition or subtraction of two matrices having the same rows, same column, okay, by using the